Hello. So now I'm back. I'm here to do a video that may help you design a slightly better robot car than the one that I purchased here. It was cheapest. It was 11 bucks, 12 bucks at Banggood. I did do a video review of this robot Arduino car, and for the most part, it's good. It's not great. There's room for improvement. You can see my previous video. But I'm here now to take this car and improve upon it, because I thought, why am I going to try to make a robot and start out with a bad foundation? So it's really critical, I think, to start out with a good platform to put your Arduino on and your motors and sensors and that sort of thing. So the first step is you need to get some plexiglass, and I happen to have a sheet of plexiglass right here that was left over from a different project. It's plenty big. It's possibly a little bit on the thin side. If you compare the two, I think the robot is slightly larger, but I'll make do. There's plenty of it, and I can glue it up and make it more sturdy if I need to. One of the big critical issues was the fact that I did not like the fact that the distance between here and here, I couldn't get the battery pack in. And if we take the battery pack and try to put it in there, it doesn't fit. And that to me is lame. I want it to fit in between the two motors, including these gears here, with a little bit of extra space. That's one of the first things I'm going to want to do. I'm also going to want to make sure that on top I have enough room for at least one Arduino, if not an Arduino Uno, and an Arduino Mega. I would like to be able to have enough room up here for that, and at least have enough room for this breadboard somewhere up here also. And then a little extra space to put sensors or switch sensors or something underneath. So this design, I really couldn't find anything better as far as the layout and the structure and the curvature and all that stuff. The way these wheels mount, these motors mount to the plexiglass right here, I really like. And I like the fact that they come through here. So they're securely mounted on there. And then when you zip tie them, the wires aren't going anywhere. One last thing I will correct is that there's a slight slope to the platform, and I don't want that. I want it level. So when I build the new platform, I'll put a spacer possibly in here. I tried to look at replacing this cheap wheel, and actually for the price and for the price point, it's really a pretty good solution. I looked at having a metal curved piece of metal that would drag on the ground, but as things got heavier, that would raise it and lower it. So I think I'm going to stick with this wheel for right now. But in the future, I may swap it out for either a better quality wheel, a smaller one that's lighter weight. I also don't want this thing to get too incredibly heavy. And then the holes. I'm going to drill large holes like this, and then other holes, but they're going to be larger than these. These are actually kind of small and not really very feasible for the most part. You can't even get really two wires through there. You can get, I think you can get maybe one. Well, what good is that going to do me? No, I want them both to go through the same hole. So I'm going to enlarge the holes a little bit. So, okay, let's go ahead and do this. Now that I've disassembled the car, taken the wheels off, and the stabilizer wheel in the back, this is the plastic decking that we are going to use. What I want to do initially, I was thinking of expanding this wider so that it would fit in between the two wheels. The battery pack would fit between the two wheels, either this way or this way. Of course, it'd be upside down, but I'm just saying, so you get the width. I'm not so sure that's a good idea anymore, because then what happens is this becomes more like a big cube, and maybe it's a little more unwieldy. I kind of like the design where it's narrow and long, and the spacing of the wheels is actually pretty good. So what I'm thinking is maybe lengthening it from here to here, making it a little bit longer so that there's room for the battery pack either this way or this way behind the wheels. And I want to be able to also have maybe a battery pack for a 9-volt or another type of battery pack that has a little bit more current and amperage. So I'm not so sure I'm going to make it wider, maybe a little bit wider, but typically I think this actually would be a good size as long as there's holes to anchor this to the deck, the battery pack to the deck, and there has to be room for this wheel, which I think I may continue to use. Even though I fundamentally don't like how big the base is, it is very stable. It does have a very good pivot, and it's basically just support. So until I find a better wheel, which I will be on the lookout for, I will use this. However, the plate for the wheel actually takes up some real estate. So we're looking at, and the wheel has to be able to pivot. So you see there's all sorts of problems now with mounting the battery underneath. This thing's got to be substantially longer. And to navigate that length, we'll have to figure out I'll have to figure out kind of where I want that length to be. So that will be the next option, and I will trace this pattern with the additional length on the plexiglass, and that I will then cut it out. Here I have the plexiglass protective plastic removed on both sides so that I can lay out the new decking for the new robot deck that I want to make. First off, we need to kind of position it here where we want it. We're going to lay tape around, this blue tape, and then we're going to mark it with a pen. It's critical to make sure that it doesn't come in crooked. We want this to be perfectly parallel to this line here. I'm going to use one of these, which is a very large speed square. You basically position it against the straight edge on the right, and you can move it in and out so it's perfectly square. You can use one of these, an adjustable 90-degree ruler. However, I have this, so I'm going to use that. The next thing is I'm going to tape this down because I need to take some measurements. So the first thing to do is check this corner here to make sure that it just comes right up, right next to this edge. I don't want it to go past. I don't want it to be too far in. I want it to be right up against it. Get the pen out of the way. And right up against it. That's very close because I needed to sand some a little bit, this corner, and heat it up to get a nice clean edge. So maybe we don't want to be right on the edge, but just a little bit of a hair over. And so we do that. There we go. And then I'm going to tape this down so that as I make measurements, it doesn't move. I don't want it to move. So now we have it here. We need to move it so that this is fairly flush. And then that's good right there. So this is right where we want it. Let's tape this down. We know that this line here is parallel to that because this is parallel to that, and this is all the way up against the edge. So here we have that. Now we want 2.5 inches extended. So that being said, these are the holes for the wheel. we need to, and it just has to be a rough 2.5 inches. It doesn't have to be exact. We want to put tape down. Let's do that first. Let's put tape down first. Now we measure 2.5 inches from the front, and that's going to be our new front wheel. 2.5 inches from the center of the hole to this center of the hole. You make a little triangular mark. So that's the new distance right there. Take this away. And we can now lay out our tape, because we need to draw a line around the perimeter. So tape is going to be here. Put this back up. So as we mark the edge here, we'll know where to cut it. This tape will go here. We know the tape goes along this edge. Here. The tape will also maybe help keep the plastic from splitting out and that sort of thing. So that's good to have also, just as a check. Let's lay this down like that. We'll take this up so that we get a little bit better control on that. Now we lay this back down. Here's the edge. Here's this edge. We want to make sure this edge also here is good. And so now once we square this all up again, we will have the new length, and then it's just a matter of cutting it out. So this edge here is good. This edge up here is good. This is good. Nice, and got to move it back just a little bit. Keep it right in. Move it down just a little bit. Okay, so there we have it. The actual position of it. Now it's just a matter of tracing it. This will help hold it in place. So we take a pen, have this in place, keep everything locked in, trace around the outside edge. Make sure your pen is at a 45 degree. So you get nice and tight in there. I'm not going to draw the holes yet. I'll have to figure out where those go. But we can take this and move it down to the new position. Oh, that's going to pull away a little bit. So what we'll need to do here is maybe use a different ruler. Let's see if this actually works a little bit nicer. So this might work a little bit better. So let's take this off, move this out of the way. Now use this. Since that's keyed in there, and we have a line right here, we can extend it to our point. This is where the new hole is going to be. And all we're trying to do is extend the deck out to that point. So this is now in the new front hole. Push this down, trace this out, trace around the back, trace around this way, move this out of the way, and there we have the majority of the extended deck. So you see how much longer? It's going to be just a little bit longer. So now that we have the dimension of the new deck and we have the actual original deck, we need to figure out where these wheel slots go. Whoever designed this deck put them here for a reason, and it's actually a ratio from the back to the front. And I want to get the same ratio from the back to the front, from the back to the wheels, to the wheel location in relation to the length of the board for the new deck. So I don't know where to put these slots on here. So what I did is I followed this form right here, which is very straightforward and simple. I have the original deck, and I measured from the back to the center of the wheel slot hole, and then I measured from the back to the front, and that's a ratio. The distance from the back to the wheel center is 4 1/4 inches, and the overall length of the deck is 7 3/4. So taking that information, the original deck length is 7.75 inches, or 3 1/4 inches, plus the additional 2 1/2 inches equals 10 1/4 inches total length for the new deck. So we take the original deck back to the wheel length, which is 4 1/4, and then we take the original deck length, which is from the back to the front, that's 7 3/4, over 7 3/4, that's the ratio. We want the same ratio for the new deck back to wheel. The new deck from the back to wherever the wheel is, this is going to be X out here somewhere, don't know where. So from here to somewhere here, we leave that as X. And then we know the new deck length, which is from here to here. So that's the new length, which is 10 1/4 inches. So X over 10 1/4. You multiply that all out, and you get X equals 5.62 inches, or the new deck back to wheel length is 5 5/8 inches. So if we measure from here, from the back, 5 5/8 inches and put a mark, that's where the center of these holes will go. So let's do that now. So we have a ruler here, and we want to go 5 5/8. Well, here's 5 inches. Here's 5 1/2. 5 5/8 is roughly right there. So we put this at the back, and we make a little mark. 5 1/2, 5/8. And that little tick mark is where the center of the slots go. So if we measure up using our speed square, you can use a smaller speed square. I'll leave that right there. Move this out of the way. The center should go, because this edge is all parallel and perpendicular. That's where the center line of the wheel is. Now it's just a matter of taking our original template and putting it over that line. It's the same width. We know where the center mark is. And the slots should go right here. There. And here. And that's what you need to cut out, and that's where the wheels are going to be mounted. Also, what's critical, since you have it here already, it's a good idea to mark where the wheel mounts go, because they have to go here. The rest of these holes can go wherever you want. But these have got to go here, and they have to be this size. And I'm talking about this. These are the holes here for these two. Here I've used pin 22 as the interrupt to here to these two wires which go to each one of these bump switches. And I've tied them together here with this resistor, and then here's the power, the voltage here. So basically each bump switch triggers one interrupt. And I'm just clipping them on here so that I can install them and use them really quick. And I can kind of move them around to see where they work the best. Let me just take this off. Take these off, they unclip. So when you turn it on, it immediately starts going forward. You have to initialize it in the code to do that. I have it set up so that if something blocks it here in the front, it stops going forward and does a stop and it looks around. In this case, it's going to turn right. The chair is that's holding the camera is blocking it. So basically, the default is always go forward. In this case, it blocks here and then it blocks over here. It'll do a reverse, and then it'll check for forward and go forward again. In addition to that, I also have bump switches here and here that are tied to the pin here that I mentioned earlier. And so if it bumps a wall, it's a bump switch, it reverses. It goes forward. Either switch, it reverses. So if these sensors right here, the ultrasonic sensors are good, but they're only good to a point. If you're at an angle to a wall or not directly straight on, they don't always give the most accurate reading. So the bump switches are necessary. In addition to that, I've also included Bluetooth, which allows me to also hook up the keyboard. And when I do that, I can also control the robot with the keyboard on the laptop. And you'll see that the light here now is solid red. I think you can see that. There you go. And so if I hit X, it goes in reverse, and it goes back to forward. If I hit D, and other letters, A goes a different direction. And so forth. So A goes left, D goes right, W goes forward. So I can kind of control it a little bit with the keyboard if I want. And here it's buffering some of the keystrokes I've typed earlier. You can hit bump switch, it'll reverse. So I use an interrupt for the bump switches again, and that makes it happen immediately. So now I'll give you a little example of seeing it actually run. So now I want to quickly describe the code to you. This has been a long video, so I want to make it quick. Up here at the top, you have all the libraries you need to include. You don't need to include liquid crystal. I have a liquid crystal. You don't really need that for your car if you don't want it. Down here, I initialize all the variables, and the limit I have set to 10. Here I have the DC motors set up on motor 3 and 4. Down here, I initialize the did bump for the bump switches to 0. Here in the setup, I attach the servos. I then go into the LCD and set up the LCD, set up the serial begin. I set the did bump to 0 so that it doesn't start out reversing, it starts out going forward. Down here in the void loop, I do use a go-to called bailout. I found that you're not really supposed to code with go-tos, but in this case it works well, so it's an option, it's a variable, so I'm going to use it. Down here we come in to set the distance. I go get the distance, the center distance, and then here what's interesting under serial 1, that is with the Arduino Mega. That's how you read different serial ports. You do serial 1, serial 2, serial 3, and so on. And then I can actually read 2 separate serial ports, serial and serial 1, and do different things. So here is the code for setting up the keyboard so that I can use the Bluetooth to control the car if I want. And then I start doing my calculation, and basically I'm always going forward. The car is always checking to go forward, and if it can't go forward, it's looking for a new forward. It'll scan right, it'll scan left, it'll find out the difference, and then it'll make a choice, either go right or left, and then go forward again. Down here you can see, if right is greater than left and right distance is greater than limit, then turn right. Else, if left is greater than right and left distance is greater than limit distance, turn left. If they both are, if right and left and forward, and again, this is triggered by a forward being less than the limit, which is 10 from above, 10 inches, then choose reverse and back up because you're in a 3-walled situation. And then these are all the distance right, get distance left. It's basically the same thing. The motors just puts out looking left, looking right. Get the center distance. Moving forward, I need to increase these numbers here. The motors don't turn evenly, so you have to increase one motor faster than the other. There were issues with batteries, these motors are not the greatest for driving a robotic car accurately. Anyway, so here's reverse, and which is the same as forward, except you're going backward command, and then you got to stop with the reverse, or else you get some jitter. Here's a left turn, right turn. Here's the whole get distance for the ping, and then here's the code for the bump switch. And all I do is basically set a variable did bump to 1, and then go back up, call the reverse, because every time you get a bump, that means you're not forward enough for the sensors to see an obstacle. Reverse and try again. So that's basically it for the code. There are some pluses and minuses with this making your own robotic car. So, some of the pluses and minuses about making the robotic car yourself versus buying one pre-made. Some of the pros are you have lots of extra room to do all the stuff you want to do. It's all on a single level. It's fundamentally the plastic and materials are relatively inexpensive and cheap. And you can purchase a plastic sensor instead of this making a metal one. So it becomes even easier. In hindsight, I would have done that instead. Now, some of the cons about this. The DC motor connection down here, where you attach the wires that go to the motor shield, very flimsy and easy to break. You break one of those, the motor's no good. Cutting the plastic all the way around was not as easy as I had hoped, and it left kind of a roughed edge. You can fiddle with it with quite a bit, but it's a lot more work. Cutting the metal here with this unique design so that they fit nice and tight, not easy to do. And I would just buy the plastic for $2. The battery pack underneath, I was able to install it underneath, which it was one of the driving forces, but it turns out that if you buy if you use batteries, say from Costco or something, this robot car drains the batteries very quickly. And those batteries, when you add them up, come out to be about 6 volts, 1.5 volts each. But if you buy, I thought, well, I'll buy a rechargeable battery, which is a set of 4, put them in instead and use that. Well, these kind of worked. However, the voltage is less, so you need more of them. Instead of having 4, now you need 6. And that adds weight, and you got to keep recharging them. So I'm still trying to solve the battery pack issue. But keep in mind, these batteries and all of this going on eats up the juice really quick. Instead of getting the 4-pack like this, they do make a narrow one that's long and narrow. I probably would do that instead, and maybe even get a 6-pack or something. Make sure when you design your car that you move the sensor, the ultrasonic sensor, back far enough so that if it hits a wall, it doesn't hit the sensor. Initially, mine was hitting the sensor, hence all the tape holding this. I had to move it. The wheel alignment here and here is very critical. These little screws that hold the wheels in. I did a good job, but I don't know if I did a great job, so it tends to turn. Now you can change that in code like I showed you, but you don't really want to do everything in code. You want to make the car well enough that it runs well to begin with. I didn't know, so I could make the holes bigger and put some washers and realign the wheels so they're a little bit more true. You can see this one's a little bit out right here, but all in all, it works well, and I'm happy with it. Let's see, the next thing is wheel speed is uneven. Wheel turning, the number of rotations that the wheel does is not accurate. Maybe some other type of motor would be better than a DC motor. I know you can add some sort of wheel that has notches so that can sense that, but even that doesn't work so well. So I probably wouldn't use DC motors for a robot car because of the uneven speed. You want to be very precise for turning and everything else. That affects the wheel turning left and right and that sort of thing. The last thing, I think that's just about it. Oh, the last thing is with the bump sensors here in front, here and here, the code calls for initiating an interrupt, and then you read the pin, and then the next there's a comma, and then the next variable is the routine, like bump switch routine or function, and then the last variable on the interrupt is when do you trigger it, and there's like 4 variables. One of them is change, meaning if it goes from plus to minus, there's one that goes from high to low, low to high, and then there's, I don't remember what the 4th one is. But you don't want to use the change because the change is actually a 2-part bump, meaning if you bump it, and I'll show you here, the car starts to run, and as it's going forward, you bump, it looks like it hits the bump switch once. But actually, let me turn it around this way. If you look forward and you bump the switch, it looks like it bumps once. But in actuality, you'll see the wheels turning. It bumps once, and then when it pings back, it bumps again. So it's actually bumping twice. So don't use the change command. The change command is not, or option is not a good option to use. I recommend using either the falling or rising option. Well, I hope this answers your questions, and please like or comment or share or subscribe to these videos. Again, I'm doing this all on my iPhone, so sometimes the videos aren't as super clear. I don't have a website yet for the code. That's why I scroll through the code slowly. You can see how it works or copy it. Or if you want, you can try emailing me and I'll try to send you a copy of the code. Thanks for watching. Take care.